Hello, this is Mrs. Kraft. This is a video of day 30, graphing exponential and log functions for those who missed class today. So here we go. We're going to do a review of how functions transform with a, h, and k. So I want to put up here as a reference the general form. This is called the general form, okay, for exponential. Y equals a times b to the x minus h plus k. That's the general form for the exponential. This is the general form for the logarithmic function. Y equals a times the log base b of x minus h plus k. So let's remember how functions shift. When I have the function x and I have x minus a, which we see up here as h, what happens? I shift right a units. When I have x plus a, what is that? That is x minus a negative a, right? So what does it do? It shifts. I have a negative a, so left a units. Now, when I have an f of x minus a, that's really like a k, okay? So that's our k up here, f of x minus k plus k. So what's happening here? I am shifting down a units. And if I have plus a, I am shifting up a units. Okay. Now, reflecting a function. If I input the negative of x, the graph reflects over the y axis. Okay? And think of it, if you have a little picture, okay, of a graph, and you take, here's the positive x, we'll call this just 2. If I take where is the graph at negative 2? If the graph at positive 2 is 4, what is the graph? Well, it doesn't matter that it's positive. What is, when I take the same function at the negative value, it's going to flip over the y-axis. When I take the negative of the function, so here I have the graph, the function, the answer is 4, the y value is 4. When I take the negative of 4, where is it? Well, it's down here. This reflects over the x-axis. So those are reflections, and we know that when we have a negative a, it flips the graph upside down. So we're going to do a little table here. This is all completed. This is really x minus negative 3, right? So what's happening? We're shifting left 3. What does it look like in an exponent? 3 to the x minus h. And what does it look like as a log? Log base 3 of x minus h. Let's look at this one. Here, what are we going to do? H is 5. So we have a shift right 5 because h is positive. And how does that look like as an exponent? Y equals 3 to the x minus 5. Then we have the log base 3 of x minus h, x minus 5. Now, if a function shifts up 2, what does that look like? F of x, and the whole thing shifts up 2. That's the k. That's what k does. So it's y equals 3 to the x plus 2. The log base 3 of x plus 2. That shifts the graph up. This function, written like this, what's happening here? It's shifted down 7. So that looks like f of x minus 7. Now, over here, it's going to, as a log function, it's going to be log base 3 of x minus 7. Now, what's happening if I take the negative of the function? That reflects over x, okay? And that is 3 negative 3 to the x, because it's the negative of the whole function, and it's the negative of the log base 3 of x. Now, when I have the log base 3 of the negative, I take the negative of, use negative x. What does that look like here? It's 3 to the negative x. It reflects over y, and it's f at negative x. Okay? Now, all of these, this whole table has a parent function, the same parent function of y equals 3 to the x. It's just shifts. All right, let's be careful about reading log functions. These two functions are very different, f and g of x. This one, this right here is what? It's a k value. So this f of x is shifting down 5. But this is the h value, so this graph is shifting right 5. Okay, so be very careful as you look at graphs. All right, let's keep moving. Now, parent functions. Parent functions are the graph without a, h, or k. So if I have an exponent, box this in, okay? Exponential functions, that's the parent function, the b to the x. That's the heart of it. For log functions, the function is f of x is log a to the x. You could say b. I'd rather it said b. Log base b of x. Okay, where a is any positive number. Remember, any positive. You can't negative. Besides 1. A is greater than 0. A does not equal 1. Okay. So what are we looking for the parents? The parent here is right there. We take away a and h, and we've got that. M of x. What's the parent? Equals 5 to the x. G of x is equal to log base 9 of x. That's g of x. And then p of x is equal to just 2 to the x, right? This is a reflection over the y-axis. So h of x is equal to the log of the 1 to 1/3 of x. And L of x is equal, this is a, this is k. There is no h, so my parent function is just 4 to the x. Okay. Looking at these two exponential parent functions, parent being they have no a is really just 1 times this. So this is really y equals 1 times 2 to the x minus 0 plus 0. That's the parent function. Let's look at these parent functions. Where do they intercept the y-axis? Y-intercept is what? 0, 1. What are the asymptotes of both of these functions? They're right here. Okay? Y equals, the line y equals 0. So what I want to tell you is that the asymptotes of all exponential functions are y equals k, whatever k is. The graph just shifts up or down. The domain is all real numbers. And the range of the graph, where does it exist on y, is 0 to positive infinity. Now let's compare that with logarithmic graphs. What's the asymptote here? The asymptote is not y equals 0, but x equals 0. Vertical. With logarithmics, we have a vertical asymptote. And the x-intercepts, now we're going to intercept the x-axis, and what is it? It's 1, 0. The domain, what's happening on x, is 0 to infinity, but not including 0. The range is all real numbers, because it exists everywhere up and down. Keep moving. Now we're getting to actual graphing. And I'd like to start with the exponents because I think we're more familiar with that. So I think this will be more intuitive. Okay. So these are our steps. We identify the parent function. We plug the values, these 5 values, in for x. We graph those points, and then we look at h and k and transform according to those transformations. Okay, so let's do it. The parent function of this graph is y equals 5 to the x. This is what we're going to put in the table. That's what the table's for. So I am going to do the parent in green. And what I'm going to do is I'm going to we already put in the values right here, and I'm going to now calculate them. What is 5 to the negative 2? Well, that's 1 over 25. And when I put in negative 1, I get 1 over 5. What does the negative do? It flips it to the denominator. 5 to the 0 is 1, 5 to the 1 is 5, 5 to the 2 is 25. There's my table. Now I am going to graph my parent function. Now I know that the parent function is always y equals k, and k is 0, so I have an asymptote for my parent function of y equals 0. When x is negative 2, y is really tiny, and this is just a little bit less, a little bit bigger, and then 0, 1, 0, 1, 1, 5, 1, 5, and then I really don't have to graph 2 because I'll be off the paper. So let's just sketch in this graph. Okay, that's the parent. Okay, this is y equals 5 to the x. Now for shifting. I graph the parent function. I'm going to transform it. Let's look at the transformation. What is the transformation here? Well, h is 4, so it goes right 4. K is negative 2, so it goes down 2. Right? 4 down 2. So I'm going to take the intercept. I'm going to start with the intercept, and I'm going to move it. I'm going to move it right 4 down 2. So I go 1, 2, 3, 4, and then down 2. 1, 2. And I've transformed the point. I'm going to transform this one other point, and I'm going to take this point and go right 4. 1, 2, 3, 4. So that's at 5, down 2. So it's at 5, 3. I've transformed both of those points. Now before I draw my graph, I want to write in my asymptote. The asymptote of the transformed function, so the asymptote is what? Y equals, what's k? Negative 2. So let's graph y equals negative 2 first. So we have an asymptote of negative 2. Y equals negative 2. Now, with 2 points and an asymptote, I can easily graph my function. So this function is y equals 5 to the x minus 4 minus 2. What I would like you to do is use these same steps to graph the example on the bottom. Okay, so stop the tape, do the example, the other example. I'm going to move on to the next page. So here we're going to graph logarithmic functions. They're the same in most ways, but slightly different. Let's look for the differences. What do? We identify the parent function. So looking at this function, what's the parent? Y equals the log base 2 of x. Now, this is where we have a difference. We plug in these values, these 5 values for y. So see that we plugged them in for y, not for x. Then we graph the points. Now, to graph the points, write the corresponding exponent function. Okay, and here's what I mean. We know that the log base b of y equals x, right? So let's write that. 2 to the y is equal to x. And remember how we do the loop. 2 to the y is equal to x. That's how we transform from a log to an exponent. And I could say log base 2 of x is y. Okay, so that they work back and forth. So now I have 2 to the y, which I have y values, is equal to x. So now I can get my x values. What is 2 to the negative 2? Well, that's 1 over 4. 2 to the negative 1, 1 over 2. 2 to the 0, 1. 2 to the first, 2. 2 squared is 4. Now I have the table of my parent function. Let's graph that. Now, we said before that the parent function has an asymptote the asymptote for logs is x equals h. So there is no h here, okay? So we have an asymptote of x equals 0. So let's draw in the asymptote of the parent function. I'm doing parent in green. Now let's graph this. When x is 1/4, y is -2. When x is 1/2, y is -1, 1, 0, 2, 1, 4, 2. Okay? This is the parent function, so I'm going to graph it in. Now, we're going to transform the parent. What is the transformation of the parent? Let's go back up here. What is the transformation? Well, h is 6, so it goes right 6. K is 3, so it goes up 3. Okay? So I'm going to take the intercept, and I'm going to go right 6. 1, 2, 3, 4, 5, 6, and up 3. So I go to 7, 3. Okay? And the fact that they're close to each other is totally random. Now I'm going to take this next point, and I'm going to go right 6 and up 3, and that's going to take me up here to 8, 4. Okay? Before I start graphing, I'm going to write my asymptote. The asymptote is what? X equals h. What is h? X equals 6. So I'm going to draw an asymptote at x equals 6. There's my asymptote, x equals 6. Now I'm going to just sketch my function, which goes to the asymptote but not ever crossing it. Okay, so now I have y equals the log base 2 of x minus 6 plus 3. That's my transformed function. This was my parent, y equals the log base 2 of x. Okay, so now I want you to do the example at the bottom. Okay, and that'll finish the notes. And then 2 things to make up in everything we did in the class. This will be your homework. Okay, you picked this up the class before, and it looks like this. We never got to graphs, so it's just a standalone worksheet for graphing. Okay, that's your homework. Also, to make up your classwork, I want you to look at, we did what's called, I call it a prepare to compare. Okay, so I'm going to make a few edits, and then I want you to complete this exercise. First, we graphed the y equals 10 to the x and y equals log base 10 of x. And we looked at what we see when we graph these functions, right? The same function. I want you to do them in different colors. You're going to, now here's what we're going to do. You'd only need to go from -2 to 2. And I don't want you to do I actually want you to use how we did. -2, -1, 0, 1, 2. Okay? So graph the exponent and the log and look at your asymptotes, domain, and range. Okay? Now, that's one. And then here is a shifted function. Now here, what I want you to do for this is, first of all, we're going to cross out 3. All right? We're not going to do an A. An A shifts the graph in pretty complicated ways, and we won't do that by hand. Okay, you can do it, but it's not intuitive. So I want you to graph, remember what we do. This is graphing the parent. Okay, what's the parent here? Y equals 10 to the x. These tables are for the parent. This is parent, okay? Y equals the log base 10 of x. Now, I want you to do it, again, the same way we did the other. Okay, so make that change, okay? And I will tell you right now that A expands the function. And we remember that A also reflects over the x-axis. It expands the function and or contracts it and reflects over the x-axis. Okay? Now we're not worried about A right now. So therefore, you're going to do those two examples. Then you're going to look at this sheet, and I want you to cross this out. It makes it easier. And this. And I want you to write, just jot down the differences of the domain, the range, and the asymptotes between y equals 10 to the x minus 1 plus 5, the graph you just did, and y equals the log base 10 of x minus 1 plus 5. Okay, those are item 1 and item 2. Show how they're different, how they're the same. Then, once you've got these facts down, just write the facts. Then I want you to write out in words, write a summary to describe the similarities and differences between exponential functions and log functions. This will be a graded classwork. Please have that in as soon as you can, at least in the next 2 classes, okay? All right.